This is Ethan, Tommy, and Evan, and we chose to do linear motion analysis. Linear motion analysis is used to determine the behavior of an object in one dimension. Linear motion can be used to determine the direction and the acceleration of the object over a certain time interval. Linear motion can be used when you have a position, velocity, or acceleration function. The position function is given by s sub t, and we know that the derivative of s sub t is equal to the velocity function. And we know the double derivative of the position function also is equal to the derivative of the velocity function is equal to the acceleration function.
Here's an example problem. A particle is moving along a horizontal line with the position function is given. Fill in the chart with intervals for which the particle has the indicated behavior. The given position function is s of t equals t to the third minus 9t squared plus 24t minus 11. The first step is to solve for the derivative of the position function to get the velocity function. S prime of t equals v of t, which is equal to 3t squared minus 18t plus 24. With that, solve for the zeros to determine the interval for which the particle is moving left or right. So, first factor out 3 from the equation. Then FOIL. 3 times t minus 4 times t minus 2. And with this, we get t to be 4 and 2. Next, solve for the derivative of the velocity function to get the acceleration function. V prime of t equals a of t, which is equal to 6t minus 18. Then, solve for the zeros to determine the interval for which the particle is speeding up or slowing down. So, adding 18 to each side and dividing by 6, we get t equal to 3.
The next step, you've got to draw the sign diagrams for the velocity and acceleration functions. Here's the velocity function. And you mark your 0 points, so 2 and 4. You've got to look at each interval. So if you plugged in a point from 0 to 2 in the velocity function, it would be positive. If you plugged in a point from 2 to 4 into the velocity function, it would be negative. And if you plugged in a point greater than 4, it's going to be positive. Then you evaluate the same way with the acceleration. Draw this nice little sign diagram out. There's only one critical point, which occurs at 3. And less than 3, it's negative. And if you plug it into the acceleration function this time, and greater than 3, of course, it's going to be positive. Plug it in, check that. Now you want to separate it so you have all the intervals So I'm just dropping this dotted line down so you can see when it goes from 2 to 3 as well. Hitting pause. Okay, now you're going to analyze this chart, or analyze the sign diagrams to see which intervals you want to move over to the chart. And the velocity sign diagram, if it's positive, that means it's going to the right, the particle. And if it's negative, it means it's going to the left. And to tell if it's speeding up or slowing down, you have to see if the signs, SIGN signs, of the velocity and acceleration, if they correspond, then it's speeding up, and if they don't, it's slowing down. So if you look at the first interval, which would be from 0 to 2, it's moving to the right because the velocity is positive, but it's slowing down because the velocity is positive and the acceleration is negative. So we'll mark that over in this chart. If you look at the next interval, from 2 to 3, it's moving to the left because the velocity function is negative, and it's speeding up to the left because at that point in the acceleration it's negative as well. So you mark that over in the chart as shown. Now we need to look at 3 to 4. It's still moving to the left, but this time it's slowing down because the signs don't match up. So you mark that over in this chart, 3 to 4. And then the last interval is from 4 to infinity, and it's moving to the right, as you can see in the velocity function, and it's speeding up because acceleration is positive as well. So that's the last thing. Got a mark over here, then you're set. Okay, so now that you have that chart completed, that completes this problem. We have a little bonus question though. The question is, what, Mr. V, is the first derivative of a cow? Ponder that for a moment. Okay. We're going to have the answer. We're going to write the answer upside down so you aren't tempted to cheat. Okay, now hopefully you've pondered that question enough. And for your bonus point, Mr. V, the answer is prime rib. Get it? Signing off, Evan Burnell,
Ethan Roush, Tommy Petro.
have a nice spring break.